Hi, this is Gunasekaran, Assistant Professor of Mechanical Engineering at SNS institutions. Okay, now we are seeing about introduction to fixed beam. Okay, fixed beam, also known as built-in beam, is structural element commonly used in engineering and constructions. It is characterized by being supported at both ends and rigidly fixed to its supports. Okay, preventing rotation and translation at these points. It simply says both ends are fixed. Okay, we have some beams. Example for that images. We can assume some one beam. Both ends are fixed rigidly. Okay, it is called as fixed beam. Okay, supported condition, fixed beam have fixed supported both ends, which provide resistance to both vertical and horizontal movement as well as rotation. Okay, rigidity, unlike simply supported beam, fixed beam are much stiffer and less susceptible to deflection under load to that fixed support conditions. Okay, here load distribution is distributed load more evenly compared to other type of beams, resulting in reduced bending moment and shear force along the beam length. Okay, understanding this characteristics and behavior is fixed beam. Engineering can effectively design and analyze structures to uh, ensure the meet performance and safety requirement. Okay, assumption on boundary condition past fully restrained ends. Restrained ends. Okay, when analyzes fixed beam with fully restrained ends, engineers make several assumptions and consider specific boundary conditions to simplify calculations and ensuring accuracy in structural analysis. First assumption, linear elastic behavior. The beam material behavior linearly elastic under loading conditions. Okay. Second one, homogeneous and isotropic material. The beam material has constant properties throughout and behaves the same in all directions. Okay. Third one, small deflections. Deflections are small relative to the beam length and to not significant alter its behavior. Okay. Boundary conditions, fixed support and uniform loading. Okay. Fixed support, the end of the beam are fully restrained, preventing any transition or rotations. Okay. Uniform loading along the beam length is assumed, simplifying the analysis of internal force and moment. By applying these assumptions and boundary conditions, engineers can accurately predict the behavior of fixed beam with fully restrained ends. Okay, enabling effective design and analytic structures in various engineering applications. Okay, uniform load distribution uh, means refers to a type of loading where a constant load is applied evenly across the entire length of beam. Okay, this loading is typically represented uh, as a force per unit length. Okay, then in structural analysis, okay, uniform load distribution simplifies calculations because the load is split constantly. Okay, split constantly, leading to predictable shear force and bending moment. Okay, finally, linear elasticity behavior. It refers to a material property where the deformation of material is directly proportional to applied load, and the material returns to original shape. upon load removal. Okay, this behavior is characterized by linear relationship between stress and strain, represented Hooke's law. Okay, here in structural engineering, assuming a linear elastic behavior uh, simplifies the analysis and design of elements like beam, allowing for a accurate predictions of reflections and internal forces under typical loading condition. This assumption is valid as long as the applied stresses do not exceed the material yield strength. Okay. Okay. Thank you.